Yes, we would like to welcome you back to our new YouTube channel. It is Richard, and the channel is Physical Sciences Silver Bullet. Before I start, I would urge you to subscribe. It is for your own good, and also after you have subscribed, we'll appreciate if you interact with us and also like us. Okay, after finishing electrolytic cell, we are now coming to galvanic cell. And what is a galvanic cell? We saw it that it is an electrochemical cell in which chemical energy is converted into electrical energy. So inside this cell, what do we have? We have the chemicals which are reacting, and what comes out of the reaction is electrical energy. It is typical of the setup we find in car batteries, in dry cells, and other components and other setups. So now, where are we going to start from? Let us start from the setup. How is the setup of this cell? That's where we are going to start from. This is generally the setup, the layout of the galvanic cell. So let's suppose this is the cell under consideration, and suppose this electrode here, you can suppose it's silver electrode. Now you have to note that if this is silver electrode, the solution here in which it is masked must be a soluble silver salt. Let's take silver nitrate as the salt. We normally actually consider nitrates most of the times when we are not sure of the solubility of the salt, because most of the nitrates are soluble. Actually, all of them are soluble. So suppose it is coupled with copper. Suppose it's coupled with copper. And that is it. So if this electrode is copper, it means this electrolyte has to be soluble copper salt. Let us use this common one. Copper sulfate is known to be soluble, and one of the commonest copper compounds we can get rid of. So this is the setup. What we have here is a salt bridge, and out there is the external circuit. So suppose this is the setup we are having, and we are going to use this this setup to look at questions which are very common with the galvanic cell. This cell is normally doable. It's not as stubborn as electrolytic, and we think we are going to appreciate it. The first step for galvanic is identification of the polarity of the electrodes. One of these half cell is positive, and the other one is negative. So let's look at here. Identification of anode and cathode. What steps do we take to identify the cathode and anode? Okay, the first step, actually, you can use several approaches to do this. You can use the relative positioning of the elements in the table is either 4A or 4B. Let us look at that one first. What you do, you go to the table 4B. It's one of the tables which we normally use. It's the most commonly used one compared to 4A. Now, in the table 4B, you look at these two elements which are under consideration. And the one which comes first is anode. We normally tell our learners that A comes before C. So the first one you meet using table 4B is the anode. Let us look at what comes with the anode. What comes with the anode are some of the information we need to know. That the reaction which takes place at anode is oxidation. That one we know. And we know that the reaction which takes place at cathode is reduction. That one we know. And because it is oxidation at anode, how do you tell that it's oxidation at anode? Because you remember when you are looking at table 4B, we said that elements at the top, they are strong reducing agents. And the strong reducing agent, when it comes to redox, it undergoes oxidation. So that's why oxidation is here. And we say that elements at the bottom, they are strong oxidizing agent. And when it comes to redox, the compound, the substance which undergoes reduction, is an oxidizing agent. So that's it. So we are having oxidation here and reduction here. That's one way of identifying the cathode and anode. So when you look at these two elements we are comparing, then which one comes first? Which one is on the top of the other? It is going to be realized that the element which is on the top is copper. And the one which comes after is silver. So in other words, copper half cell, this side, it is the anode. And the silver half cell, this side, is the cathode. That is one way of identifying the anode and cathode. Now, the second approach involves use of standard reduction potentials, these values. Now, if you remember, during one of our videos, we said that the positive value implies that the reaction wants to go in this manner, which is reduction. So when you compare, these two are both positive. So the more positive, the better it is referred. So in other words, silver, according to that approach, prefers to undergo reduction. And the copper, because it has less positive value compared to silver, it prefers to undergo the reverse reaction. The reverse being the oxidation reaction, which will become copper, giving you copper ions plus 2 electrons. So, in other words, this is not a preferred direction for this reaction. This is the one which is preferred. So now we have the two reactions. We have this one for the silver, which is prefers to be in the reduction manner, and we have the copper. But we have to remember that the reaction which takes place at anode is oxidation. So which means that the reaction we are having here is the one which takes place at anode. And this reduction reaction, which we see here, is done, which takes place at what? At cathode. So this method has even given us both. It has given us, actually, it has helped us to identify um, the anode and cathode, and also it has helped us with the reaction. So from what we have just put here, what can we say? That silver is the cathode. And the copper half cell is the anode. Okay. Now, where else can we know about galvanic?